A few years ago, a multidisciplinary group with ISTAART, the Alzheimer's Association's kind of professional society, came together to start this professional interest area focused on these subcortical neuromodulatory structures. The group represents a wide variety of researchers, from neuropsychologists to behavioral neurologists and neuroimaging and biomarkers experts through neuropathologists and cell biologists. And what's really thrilling about that group is this kind of common scientific focus on these subcortical regions that are affected so early in disease progression. And what it's allowed us to do is give us all something to focus our different techniques on. And, it's all predicated on this notion that there are a number of subcortical structures that are affected very early in Alzheimer's disease, even before the hippocampus. And if we can understand why they're so vulnerable and others aren't, we might be able to detect the disease earlier, intervene on it earlier, and actually have these kind of secondary effects that prevent further disease progression. So, for example, a lot of these structures affect sleep. So if they're degenerating, you have sleep dysfunction, which we know can significantly accelerate Alzheimer's disease progression. There's also some physiological properties of the neurotransmitters they produce that might affect disease progression. For example, norepinephrine produced by the locus coeruleus has a sort of neurotropic effect on the cortex. In animal models, when you ablate the locus coeruleus, and that model might express, for example, human APP, the cortex of that animal will have more amyloid deposits when you ablate the locus coeruleus. And it's thought that that's working through these kind of neuroinflammatory pathways and these canonical BDNF producing pathways that go haywire when you lose your locus coeruleus. So our thought as a PIA, professional interest area, is that we need to invest a lot more in really getting to the bottom of the patterns and processes underlying the vulnerability of these regions. And it'll have a lot of direct effects on biomarker discovery and therapeutics for the field in a way that is a little agnostic to protein accumulation. We don't want to get to the point where you already have all these hard to remove clumps of protein in the brain. We want to stop neurons from dying. So it's a really exciting group to be a part of. It's a very young field, but we hope that a lot of people can find something relevant to them in it, regardless of your discipline. So we encourage people to join and read the position paper that we just put out. And we have a lot of other exciting activities that we're putting together.